So say that I am solving that quadratic equation. How will I know if it factors? Well, one way you can tell if a quadratic factors is finding the value of your discriminant. So your discriminant is b squared minus 4ac. Let me check and see if this factors real quick before I resort to quadratic formula or completing the square. So I'll have 3 squared minus 4 times 2 times negative 5, which if you simplify is 9 plus 40 is 49. And 7 times 7 is 49, so it is a perfect square, and that one will factor. I could factor it if I wanted to. So it's important to be able to recognize which method is the most efficient to do when you're solving a quadratic equation. So on this one, if you don't have an x term, I can just get x squared by itself and solve by taking a square root. So no need to do quadratic formula, no need to factor. Just get x squared by itself, take the square root of both sides, and don't forget you need a plus or minus I square root of 17. If you're looking at this one, well, I have x squared and x to the first, so there's no way to just rearrange and get x by itself. I can use my discriminant to see if it'll factor. So I could do 7 squared minus 4 times 5 times 8. This is my b squared minus 4ac. Oh, okay, well this is going to get me a negative number, negative 111, so not a perfect square. But even though it won't factor, I just did the part under the radical for my quadratic formula, so let's go ahead and use the quadratic formula. So I'll have x equals negative b, negative 7, plus or minus the square root. I did my b squared minus 4ac, all over 2 times 5. So you have I times the square root of 111 all over 10. 111, let's see, those digits add up to 3, so it should be divisible by 3. It's a fun fact. If you add up the digits and they divide by 3, the whole thing does. But 37 is prime, so that's our final result. If I look at this one, I could get 0 on one side and try factoring or quadratic formula, or it's already kind of set up for completing the square, and it's one where it would be nice to complete the square since it is a 1x squared and 6 divides nicely in half. So we are gonna complete the square. It's my favorite anyways. So let's see, we've got x squared plus 6x. Well, since I'm creating a square, cut that 6x in half. That'll give us an area with a rectangle of 3x area on both sides. So side lengths of our incomplete square, once it's completed, will be x plus 3. And then that little corner has dimensions 3 by 3, so we need 9 units to complete our square. So I can add 9 units to both sides of my equation. Don't forget to do it to the right-hand side as well. And then if you rewrite x squared plus 6x plus 9 in its equivalent factored form, it's the perfect square, x plus 3. Take the square root of both sides. You'll just have x plus 3 equals positive and negative square root of 21. 21 is 7 times 3, so you can't break that down. Subtract 3 from both sides to get x by itself, and you will be good to go.